Okay, so now we are gonna make the problem number 81. It's called the Mandelbrot numbers. So the statement is as follows. The Mandelbrot set is built around a simple iterative equation, and we are given this series of steps to create a Mandelbrot set. So we're gonna uh, get this equation here just to know more or less how it's gonna work. And then it says, for any complex C, we can continue this iteration until either the absolute value of the next step is bigger than 2, or if n is equal to a limit, then return the iteration count end. It's given some examples here. For example, if C is 0 and the limit is 3, then the Mandelbrot set will be 0, 0, 0, and n is going to be 3. So what they are saying is that the first value, the zeta 1 for this set, mm, let me see if I can write it, maybe it's better. Zeta 1 is gonna be 0 because in this case C is 0. For C equals 0 and then n equal, sorry, limit is 3. Okay, then since we already know which one is C1, maybe we can note that C2 is gonna be C1 squared, so again plus 0 because 0 is C. In this case, since this is 0 and this is 0, we're just gonna get 0 times 0 plus 0 equals 0. Yeah, very interesting. So we can continue with that, and we'll notice that C1 is gonna be 0, C2 is gonna be 0, C3 is also gonna be 0, and yeah, because this is gonna be C2 times C2 plus 0, and this is the same as saying 0 plus 0 times 0 plus 0. So in the end, it's just a set of zeros. When this ends, well, the limit says it has to be only 3 iterations. So C1, C2, and C3, and the answer should be uh, this one. So this is the answer for this set. We can make that with also another value like C1 is 1 and the limit is 5. Um, okay, let's make it fast just to show it. Uh, in the case that C is equal to 1 and then the limit is 5, C1 is gonna be 1 and C2 is gonna be C1 times C1, that's this, right? Plus 1, and this is actually 1 plus 1, and this is 2. So C1 is 1, C2 is 2, and when does this ends is when the value or the next step is bigger than 2. So yeah, this value 2 still is good. The next one shouldn't be, right? Because it's gonna be C2 times C2 so plus 1, and C3 is gonna be 2 times 2 plus 1, and that's 5. So since this value is bigger than 2, it is erased, it is not counted, and we just count C1 and C2, and the set ends here. We don't have to go to 5. So yeah, that's the way the Mandelbrot set works. You can make it with more complex examples. I'm not gonna take it the time to make this and to show it, but we just need to understand that this is for the absolute value and it can go within limit. We just need the limit and the number C. In this case, what they are asking us, for a matrix of complex number C, return our corresponding matrix n such that each element of n is the iteration count and for each complex number C in the matrix C. Oh my god, this seems very very complicated. Subject to the iteration count limit of lim. So what they are asking us actually is we just have a matrix, and this matrix is going to have a lot of numbers, and we also have the limit. So for each number in the matrix we're going to use it as C, like this one. So C0 and the limit is 5, then C is 0.5 and the limit is 5, then C is 1 and the limit is 5, and then C is 4 and the limit is 5. And we should get the answer as how many elements does these Mandelbrot sets would have with each pair. So how many elements with C equals 0 and the limit is 5? It's going to have 5 because there are 5 zeros. And for the other numbers we should check because I'm not sure. So let's make this. So yeah, here I already made the code. You can see that I get the 3 tests done. And it's time to show how this works. I'm not sure if I can zoom. No, so you cannot see very well the code here, so I'm just gonna show it here. It's the same, so not much problem here. So yeah, the function is Mandelbrot, the answer is a matrix n, and the input is a matrix C and the limit. So what I made is, or what I did is use S to get the size of the matrix, so I can know how many rows and how many columns this input will have. And then I call D1 for the number of rows and D2 as the number of columns. So I already have it organized. Then I make an iterative process. So since this is gonna work for every, let me see, for every value of the matrix, then I make a for I from 1 to the number of rows, and then for j starting from 1 and then until the total number of columns. The process is going to work for every number of the column of the input. I create some values here which are very important. I create a trigger because I'm working with a while command, and yeah, it has the trigger here. I'm going to explain later. Then I create the C vector which is displaying on the problem, and also I create a counter. Counter is to know how many elements this C vector is gonna have. So yeah, I just create a while that is gonna end if triggers is not 0. So you're gonna see that trigger is gonna become different than 0. It's gonna be 1 when the absolute value is bigger than 2. And then the count, or the other case, if the counter surpasses the limit. So if I say the limit is 3 and we already have 4 elements, the while stops because we don't have to do that. Then yeah, for the first iteration, which is a counter equals 1, we're just calling that C, the first element of C is going to be the same, just as here. The first element is going to be the same. And on the other cases, so when counter becomes another number, it's gonna follow the other equation, which is the previous iteration square plus C. So yeah, I'm just squaring this and then adding the original value. I know that counter is gonna be either 1 or 2, 3, 4, 5. It depends on the limit because I'm creating a command here which updates the value of counter. It becomes counter plus 1. So yeah, not negative values for counter, not fraction values, so only natural numbers. And at last I make use another statement in the case that the absolute value of this result is bigger than 2 and yeah, the counter is bigger than 1. We erase the value and we say that trigger is 1. With this we end this loop. So yeah, at the moment that this happens, this is not gonna work anymore. So yeah, that's the reason why I use trigger and why I use counter. I use this command because it says an example that, for example, if we start with 4 and 4 is already bigger than 2, we should count 4 as a element of the vector. So that's why it's here. At the end, we just said that the value of the corresponding element of end is the length of C, as was asked on the problem. And yeah, that's all the things I have to say here. Maybe I can show some examples. I'm not sure. Uh, Here are some examples of the tests. I can also show it here. I'm not sure if I should, but yeah. For example, we have the value here, and now we just need to show C. C is gonna be this vector, and the limit is 5. And we can see that we get the answer at end. So yeah, this works. This is very good. We can also make it for another example, like let me just copy this and show it. I guess Control C and Control V, yes, and the limit is 10. So we can show the final answer here. N has this set of values, and we see that it's a vector because the original input is also a vector. And yeah, that's the code. It's quite easy. Well, it's medium difficulty for me. It's like 2 of 3. And yeah, that's it. Thank you.